Okay, so when we have those, we would say that these are the coefficients of our new polynomial, right, our quotient polynomial, and if it was an x cubed, then when we divide, it knocks it down by a power of 1, so it's now x what? Squared, so we have 1x squared, negative 1x minus 20. Cool? That was the answer to a division problem because that is our quotient. However, reading carefully, raise your hand if you can tell me what the instructions in this type of problem, what was it asking us to do? Jeannie?
Factor the polynomial completely.
Factor the polynomial completely, which means we're going to use our quotient because when I talk about factors, a factor of 6 is like 2, right? That means I can divide 6 by 2 and get a remainder of 0, right? And so here, since my remainder is 0, that means x minus 3 is a factor, and I can multiply it times my answer. 6 divided by 2 is 3, right? So I could multiply my answer and what I divided by, and that should give me back to what I started with, right? So I can multiply what I divided by times my answer, and that should be equivalent to what I started with. And then this second piece, we should be able to do our box method to complete the factoring. So raise your hand if someone already did. I'm not going to go through the whole box. Their box here, and what did we get, Maggie?
X minus 3 times x minus 5 is x plus 4.
Cool. So for that section of it, we got x minus 5 and x plus 4, which brings our final factored form to this right here, right? Okay. For the next one, someone that did their synthetic division, can you tell me again, we're not going to review as much. Actually, there were quite a few people going in here. So sorry for you guys that were here. I'm going to slow it down just for a second. Can someone remind me what we put in here when we're dividing a polynomial? Oh, I wasn't even here. What do we put there? -2. We put the 0. Awesome. He's been asking his neighbors. We put -2. We put the 0 of what we're dividing by right here. Okay. Who can share with us, to recap for the people that weren't here, what we put across the top? Isaiah?
We put the coefficients of each of them.
Cool. So the coefficients of each of these terms, we just need to make sure it didn't skip one. That's why some of y'all might have done some stuff with the 22, but I didn't mean for it to be. So we'd have 3, -7, -22, and a +8, right? Writing down our coefficients. All right, cool. Now we bring down the first one. That means 3 is what we're going to start with and bring down. You get out. Bring down your 3. And then we multiply, always times our root, and then we add the columns. So 3 times -2 gave me -6 here. -6 plus -7. -13. -13 times -2 is a +26.
What?
Did I do that wrong?
No.
Okay. So multiply and write that number right here. And then we add the columns. So -22 plus +26 would be a +4. Now we multiply 4 times -2 is -8. Now we add again, 8 and -8 is 0. Okay? That last number is our remainder, and the first 3 numbers are the coefficients of our new polynomial. So our new polynomial would be 3, and if it was x cubed before, what's it going to be now?
X squared.
X squared. 3x squared minus 13x plus 4 with a remainder of 0. Okay? This would be your answer if I asked to just divide. But did I ask to just divide?
No.
So this is not our final answer, so don't box it yet. We now need to factor using this. So we're going to do x plus 2 times 3x squared minus 13x plus 4. Okay? Alright, from here, we can finish our factoring by doing the box right here. Isaac, question, comment? You're ready to share what you got? Okay. He did his box for this. What did you get when you did your box?
3x minus 1 times x minus 4.
Cool. So he got 3x minus 1 and x minus 4 from his box. So those are our factors of that last one. Sit up so they said you won't fall asleep. Perfect. Okay? Y'all with me?
Yes.
Okay. So final answer, if they ask for the dividing, is your quotient polynomial. But if they ask for you to factor, this is not your final answer. I just want to point that out. So I know you're showing him, which is great, but that's not your final answer. For this type of problem, which you're going to be asked for a lot, this is our final answer. Did you get this?
Yeah. You just told me that. I didn't see the answer.
Okay, cool. Any questions about factoring? Since we kind of rushed through that at the end of yesterday. Okay, cool. Moving on. Tomorrow you have your first quiz for Unit 2, okay? So keep that in mind. That means it could cover anything from that first problem set. So on your first problem set was a lot of those graphs where you had to find your different zeros by factoring and decide whether it bounced or crossed, decide whether it's even, positive, even, negative, what was happening at the ends, all of those things, okay? It also could have anything with solving radicals, things like this, okay? Where we have to isolate the radical and then square both sides or do the power of both sides. It also could have anything with the regressions that we did on Friday. And I'm going to repeat this again, I kind of mentioned this yesterday. On the regressions, tomorrow on the calculator, I can't show you where in your calculator to go to do the regression. So make sure you practice that on your problem set or go over the steps again tonight so that you have them ready to go for the quiz tomorrow and you know where to go in your calculator. Cool? Okay. You could also maybe see some synthetic because we learned it yesterday and we're going to be practicing more today. You will not see the few little new things that I'm going to add on today because today will be your first day to see them. But stuff that we did yesterday, since we're going to kind of reinforce it today and practice it again, you could see stuff like that. Okay? With that being said, a good place to go for practice is your problem set that you got yesterday. I have a few things that I'm going to change that were kind of number mistakes on your problem set that you might have noticed if you started last night, that you ran into some problems. So I'm going to make those changes in a second. That problem set is due, for those of you that weren't here, next Tuesday since you don't have school on Monday, right? Okay? A note about problem sets. In general, I gave out a lot of slips today because some people were absent, but just in general in all of my classes, I gave out a lot of missing work slips today of people that didn't turn in problem sets. So one that hurts your grade in terms of your homework grade, when your problem set should really be a cushion and should be helping out your grade because that's the problems you can ask me for help on, okay? But two, if you're not getting that practice, I guarantee you're going to struggle more tomorrow on the quiz or on the unit test in the future. Okay, so we do not always have time in here to practice 20 minutes with every skill we learn, but honestly you probably need to learn the stuff really well, a good 20 minutes with everything we do of just more problems, practicing it and getting good at it before it sticks in there. So you need to be taking those problem sets seriously. I'm going to kind of see how things continue to go because I'm starting to notice some repeat people that have just not turned in a lot of them, or I understand if you're late every once in a while, but most times we have problem sets, they turn it in a day or two late. And those people, I might change my policy and have to rearrange things because I'm not going to just let it take your grade. So I might be finding you and starting to pull you, don't be surprised, at lunch or calling home to make sure you can stay after school to work on those problem sets with me if you're not doing them on your own, okay? So I'm going to change things up if we're not getting them in. So I just wanted to put that on y'all's radar, okay? So problem sets, do them. I'll grade them. My goal was to have graded it last night so I can give it to you today so you can study it for your quiz tomorrow. So if you didn't give them to me, then please get that in ASAP. Okay. Problem set 2. Everyone go ahead and grab it because I got some changes to make. Grab your problem set 2. Carmen, grab your problem set 2. Really quick, I'll give you 30 seconds to grab it because I'm going to make some adjustments to things that I said the numbers were less friendly than I expected, okay? Alright, grab it, but still keep those voices off so I can keep going quickly. Isaac, Quan, thank you very much. Okay, so first up, problem number 1, first mistake. Whoopsies. So Chimmy, I know if you already solved it this way, like Chimmy yesterday did it, and we noticed that it didn't factor super easily. So he went and like he did his quadratic formula, I believe, which is fine. And Chimmy, I will be careful with that cord. I will grade, like if you already did this problem, I'll grade it how it is. You don't need to like redo it, okay? But for those of you that haven't done this yet, or maybe you stopped and waited and you were like waiting to ask me how to factor it, for this one to find your roots to factor, I meant to make it one that you could factor, and I made one that you would have to use like the quadratic formula. So let's change this negative 12 to a negative 15. Just change that like 2 to a 5 and make it negative 15x cubed. And that should help you when you factor out a 3x squared. Should make things easier to do with box. Okay? Alright, that's first thing there. Just change that number. It should make your life easier later. Number 2 is good. On number 3, you might have had trouble finding an answer. Because the way the problem is right now, there's not a correct answer. F, G, H, and J are all incorrect. So let's adjust the problem a little bit to make sure that there's a correct answer. So here's what I want you to change. Y'all with me?
Yeah.
So you don't miss the change. I'm going to have you change this negative 4 to a positive 4, and this positive 5 to a negative 5, and then keep it as a double root of x equals 0. Okay? I don't know. No, it's not. But anyways. Cool?
You changed that so much.
That's not true though. I mean, I could explain it to you later, but yeah, that doesn't mean your answer's up. Okay, cool? We got it? That should be enough to solve that and have no problems. With multiple choice, do y'all have a question back there? If not, then if y'all could hold that conversation until later, or if you have a question, you can raise your hand and I'll address it, okay? Cool. With multiple choice, I should still see some sort of work on this problem, okay? If I see an answer circled on a problem set, I'm going to count that still as like not completing that question, because this one, I don't want you to do in your head to factor and find the roots. You should have to actually factor this, and I should see some work on your paper, okay? So I also wanted to point that out about this problem. Happy? Okay. Those are your announcements about those problems. If you made those changes, you should be set up for success. You'll be good to go. All right. Today, we're going to be talking about the remainder and the factor theorem, which are very similar to, and again, since we're done with that problem set, if you can put it away, I know it's tempting, you're like, ooh, I want to just keep working on it real quick, but put it away or I'm going to take it from you, because that's going to be homework. In 2 of my classes, we finished the practice a little bit early and they got to work on the problem sets, so if you do the same, I'll give you that, but we got 30 minutes to get through still a couple new things about synthetic division. Cool? Okay, so from the top, let's talk about the remainder theorem. The remainder theorem is talking about the remainder, which means if you think of synthetic division, we're talking about this like last number we get right here, right, is our remainder. Sometimes it's 0, sometimes it's a number. The remainder theorem says that a polynomial f of x is divided by x minus c. If it is, then the remainder r is actually equal to f of c, the same value that you would get if you plug c into your function from the beginning. Which makes sense because if this is 0, like we just talked about with it being a factor, that means that this, like let's say it was 3, that means x minus 3 is a factor, which means 3 is a root or a 0. Like literally f of 3 should give me 0 on my graph, right? So this number right here is actually the value of our function at c, okay? So let's talk about that. That's, yep.
So 3 would be the c, right?
Yeah, so
Okay.
if I say f of 3 for this function, if my remainder was 0, we know that's literally like means it's a root. And so this value right here is actually the same of f of c. If it's a number, like 12, then f of 3 actually would not cross right here. The value of this function would actually be 12 as well. So the interesting thing about that is it's actually, synthetic could not only be used to divide, but synthetic could be used to evaluate functions at different points, right? We know we could just plug in the number, right? But synthetic, some people might find easier in some cases if the numbers like work out to be friendlier with synthetic. For example, in this problem. So let's take a look. Can I get someone to read this problem right here? Jason, go for it.
The number of tickets sold during the Northside High School football season can be modeled by Tx equals.
Yeah, you don't have to read the link. T of x.
Where x is the number of games played. Use the remainder theorem to find the number of tickets sold during the 12th game of the Northside High School football season.
Okay, so you got a function for tickets based off of x, the number of games. We want the number of tickets for how many games?
12.
So we want t of 12, which before today, raise your hand, let's summarize one more time. Raise your hand, what would we do before today to find t of 12? Justin?
You plug it all into your equation.
You would plug it in, which we're going to pause and we're not going to do for right now, but like literally, if you would like to write this, you can, but we're not going to do it this way. You could plug 12 into that whole long thing. But notice, you would probably need to use, not just your brain, you have to probably use a calculator for something like that. That would be kind of mean if I gave that to you on a non-calculator, right? You gotta do like 12 cubed, like all that stuff, okay? So, what we just talked about though, is that t of 12 should also be equal to that remainder value when we do synthetic, right? So let's set up our synthetic and see if we like synthetic as a strategy to solve this problem, okay? So if our c is 12, and we write the coefficients of our polynomial, we would have a 1, negative 12, 48, I'll go to the second, and a 74. So I just took the coefficients like we did in the first and like we did yesterday for that. Yep. Yeah, well, did I miss something? Oh yeah. Oh, here, you're saying. So it's x minus c to find f of c, f of 12. And so we would find the root of this, which is 12. Cool? Good question. Okay. So now, we bring down the first one. People that weren't here from yesterday, you're still kind of like catching on to this. We bring down the first one, and then we're always doing one operation with the root right here. 1 and 12, we're going to do what? Multiply. Okay, so we're going to multiply these. 1 times 12 is 12. And then we're going to add the rows. So negative 12 plus 12 is 0. Multiply 0 times 12 is 0. Add 48 plus 0 is 48. Multiply 48 times 12. This is probably the first time that you got like a difficult math problem to do versus like this, right? Technically, I could still give that to you on non-calculator, like that's kind of a big number, but you can do by hand if I asked you to this, right? And I believe you get 5, cool? And then add those and you should get 650. Since it's a word problem, raise your hand if you can tell me 650 what? What are we talking about? Raise your hand, raise your hand. Just for your units, someone help me out. Chris Ball? Tickets. So 650 tickets. Did I ever get yours? 650 ticket. Oh my gosh. There we go. I hit the wrong button. 650 tickets would be.
Oh, that's fit. I'm sorry, I missed that.
650 tickets would be our answer. Cool? Okay. Raise your hand if you feel like, y'all can be honest, because again, these are like two strategies that give us the same answer. Raise your hand if you are, from the last like day and a half or whatever, are kind of actually liking synthetic and you feel like this might be a strategy you're like interested in using. Okay, so I wanted to show it to you because I think the remainder theorem is kind of cool and might make problems like this a little easier, and technically then I could put it on like a non-calc section and you could do that by hand. Yep.
So like how would you write a remainder?
Little, if everyone else, again, those voices off while someone else is talking, and you nice and loud. I'm gonna start.
Sorry.
How would you write a remainder like if it asked you to put it in factor form? Like what would you put?
Gotcha. So if you have a remainder, we're gonna talk about that in a second, but if your answer right here is not 0, then x minus 3, if that's what you're testing, is not a factor, right? Like if I say 6 divided by 4 and I get a remainder, we say 4 now is not a factor of 6. It's not a factor unless it goes in evenly, okay? So that's why all the examples you saw where we wrote it in factored form, we got 0 as our remainder. Cool? Yep.
So by it not being a factor, it means we can't factor it, right?
If it's not a factor, it doesn't mean it can't be factored, it just means that one you were testing is not a factor.
Okay.
Maybe there's others out there,
Okay.
right? Like 4 is not a factor, but that doesn't mean 6 doesn't have any, like it has 2 and 3 and like other numbers, okay? Cool. Alright, so we got 650 tickets. I want y'all to practice this. So this is us, we're gonna do one more remainder problem. Let's find 13th game, how many tickets there could be, and I want you to try it with synthetic so you can see if you like it before you go back to just the plugging in method, okay? Try it for 13 games, same thing, but for 13, see what you get. I know it's last period, but I need you to stick with me. We can get through more problems if we just move a little quicker. So for 13 games, I want you to do the same thing. For 13 games, I want you to do the same thing. So just draw your box, 13, all the same stuff. Mm-hmm. So you're gonna go back to the beginning and like basically erase the second row I have. You can use the same top row. And you're just gonna do it for 13 now. No, because that's a 13, all those multiplications are gonna be different, right?
Are you serious? That was just
I know. But the only thing we did yesterday is we wrote these as polynomials. Okay, so this would be 1x squared plus 0 basically. Oh, x. So the remainder, that last one, we add on. So this is so when you say 6 divided by 2 is 3, 3 is your quotient, is your answer. When you divide polynomials, your answer is going to be okay, today we're using, same thing, synthetic, we're dividing, but we're using it to solve a problem, like we're not using it to okay?
And this will,
Unless I ask you to like explain your answer, but here you would just say like, there's this many tickets, which isn't like really Alright, I'm gonna bring it back, I'll keep answering questions, but most people should be done with this one. So, Carmen, you wanna see what you got? Something like this? What'd you get? Perfect, 867 tickets. Stand for you, get out your tracker. Okay, 867 tickets. So, remainder theorem, we're gonna leave it behind. We're gonna move on. Wake yourself up. Like I know I see a lot of people leaning in on their arms, which I'm just gonna remind you to sit up because I know that's how we fall asleep. Y'all can sit up perfect. I know. Last period, we gotta stick with me. Important stuff to get your quiz tomorrow. Okay? So, remainder theorem. You can use it. It's cool because it helps you to evaluate functions. But we're gonna focus the rest of our energy on something we call the factor theorem, which actually is what Maggie asked about and kind of what we talked about in our do first. The factor theorem is like a fancy name for something we've really already talked about. It says that a polynomial f of x has a factor x minus c, like x minus 3, x minus 2, all the things we've been doing, right?
Yes, sir.
If and only if f of c is 0. The only way it's a factor is if it goes in evenly or we get a remainder of 0. So one more time to repeat what Maggie asked earlier. take a look at my example with 6, is 4 what we call a factor of 6? No, because when I divide by 4, I get a remainder, right? 2 is a factor of 6 because 6 divided by 2 is 3 without any remainder, right? You can divide it evenly. Okay, so what we're going to do here is we're going to read these instructions. All of these things are using synthetic, but you got to pay close attention to your directions. We were asked yesterday to divide, and our answer was a quotient polynomial. You were asked to divide, and your answer was a quotient polynomial. That was one thing we had to do, okay? Another thing we had to do was then we actually did this more today in your class because it was a continuation. We had to put it in factored form. That was another way that we used synthetic. Now what we're going to do is use the factor theorem to determine if the binomials are factors. You're basically going to be saying it's a factor or it's not a factor. Okay, so we're going to have to answer that question. And then use them to write factored form. The same thing that we did in the do first. We're going to be factoring. And I'm going to write a little clarifying right here if we can, because there's going to be a couple examples we see today where y'all are going to get stuck, and I'm going to have to give you a little bit more info about how to keep going. Yep?
We have to do 2?
Yeah. So what do you notice? Right here? There's 2 factors. This is basically 2 separate problems that they're asking you to test x minus 1, and they're asking you to test x plus 3. So you should have 2 yeses or 2 nos, or a yes and a no of if they're factors or not. Okay? So let's model, let's test the first one together. Okay, if we're testing x minus 1, we're going to plug in here 1, and then we're going to write down our coefficients. Go ahead and take a second and do that synthetic for me to see how you feel about that. I'll do it up here, and you can check your work as we go. Do it on your own, but see if you get the same thing as me when you're done. Okay, as you finish, check your numbers, see if you got the same thing with the key up here. Okay, so again, let's think about what our question asked, because this is where I saw a lot of people kind of struggle last year, is they did synthetic and then they like sometimes wrote down the polynomial, other times people were factoring and they were doing it without really paying attention to the directions. So here, it asks, is x minus 1 a factor of our polynomial? So your answer should, it'd be cool and all if you wrote out the polynomial, but what I want you to answer is a statement that says yes or no, it's a factor. So raise your hand if you can tell me from looking at this whether x minus 1 is a factor or not. Chimmy, what would you say?
I would say that this is not a factor.
X minus 1 is not, just what we would have to write down, a factor. And if they ask you why, I didn't ask you why, but if they ask you why, Chimmy, can you explain why you said it's not a factor?
It's not a factor because the remainder isn't 0.
The remainder is not 0. If it's a factor, our remainder will be 0. Okay? So he answered that question. Is it a factor? He said no, it's not a factor because our remainder is not 0. Okay, cool. For x plus 3, this is not like the example yesterday. Yesterday we did like 2 that were multiplied together, and we had to divide by the entire thing, and we did them like consecutively, right? In this case, we are not going to use these numbers, right? Because we didn't get a remainder of 0, so this is not like our new polynomial that's been divided by x plus 1 that we're going to use for x plus 3. For x plus 3, we're going to go back to the original and say negative 3, 4, 21, 25, negative 5 is 3. Go ahead and do your synthetic again to check and see if this one is a factor. So then write down this, because what goes here is the 0 of our binomial that we're dividing by. So it's what makes this 0. Negative 3 plus 3 would be 0. So you're 1 minus 0.
So whenever like, is there a problem that they
You finish this?
How about the base last time? But if it's minus, then it's like a polynomial.
Yes. Because technically we did flip it because what we were doing here is x minus c and our c is 12. So we were testing x minus 12 for x minus 12. Got it? Okay. Really quick. It's not the brain's problem. Let's get about her. So dude, hold So this one was true, and this one was not true. So there was no 2 of them. That's why. But it's good. I need to say more because I can those are
Look at you! Look at you!
But your drawing
No, I just went on the negative.
wouldn't look, the ends would look like that, but it should cross at those 3 points and either bounce or cross. Okay? If the numbers are too crazy big, I won't put it on that. It'll be reasonable. Okay, bring it back. Let's go with someone I haven't heard from in a while. Samantha, coming over to you. Everyone else voices off. Samantha, what did you get as your remainder for this one?
0.
0. So I'm not going to check all the numbers, but this one should have worked. You should have gotten 0. So Samantha, what was your conclusion?
That x plus 3 is a factor.
Is a factor of f of x. Okay? If it is a factor, don't go on to the next problem yet. If it is a factor, keep in mind, again, reading our directions, that we need to at least try. We need to at least try and see if now we can factor the polynomial completely using our factor. So like we did in the do first, if this is a factor, then that means this times what we got is equal to our original polynomial. So I actually do need y'all to help me out. Can someone read for me another stamp opportunity what those coefficients were that you were supposed to get here, Leslie?
4, 9,
A little louder. 1? Okay, so we would have had 4, and if this is a polynomial that used to be x to the 4th, our new polynomial is going to be x to the 3rd, so 4x cubed plus 9x squared minus 2x plus 1. So we're on our way to factoring, but do you guys know how to factor something cubic like that? No. The only strategy, oh, sorry, and I missed yours. And I was late. Okay. The only strategy you have, stick with me, the only strategy you have for factoring something like this is using synthetic, right? We just learned synthetic. But I would have to give you other factors, or on Thursday, you're going to have to learn, other binomials, and you're going to learn on Thursday how to, pick those yourself. Yep?
I know that, you can, do it, kind of separate them, and then try to find a factor of the first 2 things, and then try to find the factor of the second.
So there's ways for us to do this, but y'all's kind of go-to at this point is either synthetic or your box method. And so I'm going to kind of table this, and if you want to completely try to factor it, if you've got a strategy, you can go for it. For right now, today, I'm going to say if it's a quadratic, I want you to finish it off. If it's not, then leave it as far as you can get, and you can go on and practice the next one so we can keep practicing the synthetic piece. Cool? Awesome. If you have it though, Maggie, I can come check it. Okay. Alright, so our answer is x minus 1 is not a factor, x plus 3 is a factor, and we tried to write it in factored form. We just got stuck, and so we're going to leave it. In some other examples you're going to see in a second, you should finish off with a factored form because it should be a quadratic that you can do that. Okay? Alright, on to the next one. You guys are going to try right now. You've got 11 minutes of focused practice. I should see you get past just B. You should be going on to the one at the bottom as well before time's up if you're working with a sense of urgency and you're focused. So you're testing both of these, factoring it if you can, And then you can go on to the next one. And I'm gonna wait on bathroom until you at least finish B. If you finish B, you can have me check you off and then I'll let you go. You're doing good?
I did that.
This thing is cold.
You ready?
I thought I had it written down. So I'm ending up with a minus 8x cubed already. So something here. Cool. So now you should be able to write it complete without it. Cool. Adrian, how did you get? There's a minus 1. Okay, so this is the factors. This is not the complete factor one, right? These are these two factors, but they're technically should be to get x cubed. You're going to need 3, right? So you're going to take one of these, doesn't matter which one, and this is technically, right, 2x squared plus 9x plus 4, right? Times this. And now do your box for this. And one of the ones you're going to get from this is going to be x plus 4, right? You know, we're missing that, and that's also and then you'll get like x plus 4, and then you should get something else. Back here, and then when that so headed back here, yeah, close to this. Let's use this one. We've got x minus 5. Wish you had that times 90, Adrian, keep going please. You got all that whole next page. Keep going. No laughing until you finish all your done. Okay. Then you have 2x squared. If you get to pick now, because what's going to happen is if you factor 2x plus 9x plus 4, one of the factors of this is going to be in your box x plus 4. And that's also there. If you do this one of the factors is going to be x minus 5, and you have to figure out what that is. So pick one side, like we just picked the positive one plus 9x plus 4. Now we're going to do a box with this. Combine those last two factors. Yep. Did you get both of these for factors? No. Well, actually you can. Either one. Yep. You can. Okay, we are looking for factors of 8.
They're both factors.
So that one I said if you can, and the direction I said if you can, clarifying, if you get something to go, you just know.
What am I doing?
So for this, you know what to do when you have 2 raised.
Math is like, right?
Multiply 4 until you get 8. you're looking for factors of 8, that would be 9. Right?
No, not a factor.
1x and 8x. Should be good. Do y'all finish?
Yeah.
All of them? All the way to the back? Did y'all finish? Keep working. Go, go, go. You got 6 minutes left. I want you to definitely get to the problem on the bottom as well. And then keep going on to the back. 1 second. So then pull out your common factors. This would be a 2x and an x. This would be a 4 plus 4 and a plus 1.
Oh, wait.
So notice there's that x plus 4, which we already said was a factor, right? We said x plus 4 was a factor. So we don't need to go back and do the box here too, like we got those. Yes.
For the bottom, the second one's not a
We're asking
factor.
with this one because these out of these have a factor point and not
X minus 5.
you can't because if you put the 2x here, then the 8x would have had to be down here to have the common 2, which meant this would have to be a 1 and this would have to be 2. Yeah, it's fine on either side, but the 2x should be with the 1 and the x should be with the 4. So you got x minus 5, x plus 3, 2x plus 1.
The second one's not a factor. Yes.
It will give you the same thing once you're all done. Because this one will give you the missing x plus 4 factor and the other one. This one will give you the x minus 5 factor and the other one. You see where we're at? Okay, so we got the third factor. Now we're just working on our box factor. It's gonna be the x minus 5 that you're missing, and 2x plus something else. So you only need to do your box on one of them. You get to choose because they're gonna end up giving you the same 3 in the end. This one is gonna give you the x plus 4 that you're missing and something else. This one's gonna give you the x minus 5 that you're missing and something else. So just come in for one box and get it, and then you'll have your factor. Oh, I think that looks right. So I think only one is a factor. But that should be enough for you to factor it. So in both of these examples, you then need to go and write your final factor form. So for this one, I tried and I couldn't finish. But for these ones, you should be able to finish it off. Yeah, I think that was the answer. Let me see what you got. Focus. 3 minutes. I need you to finish at least through the bottom of this page. Okay. So right here.
You guys have the factor on the bottom?
From there you say x minus 2 times, and then you write this as a polynomial. So this would be the equation of 3, and then it goes down by 1, so it's going to be now 3x squared plus 5x minus 1. Okay? Adam. You got the 0. These should both work. So check this one. Oh no, sorry, check this one. Should have given you 0. Wait, you did get 0 here. Did you get 0? There. Thanks. Now run your first problem. Go. Go. Finish till the bottom. It's in the emergency. We're over here having too much fun. No, I missed it. Okay. These are all I want is your okay. These are great. This is great. Alright, no backup yet. Eyes up here. I had one class today that I held after the bell because we were packing up. So Pause your conversations, look up here, so that I can let you out on time. Okay, so that you can see and check some of your answers, so we haven't packed up yet, we're checking, or I'm gonna hold you. We're checking, or I'm gonna hold you. X minus 5 was, and x plus 4, and there was your factored form. If you didn't factor it, make sure you did that part of the instructions. For the next one, because we should have gotten to that bottom one if we were working with the sense of urgency, x minus 2 worked, x minus 5 did not work, and you still could have factored it with just that one helping you, and if you finished, you would get something like this. If you didn't finish it up, okay? Alright, bye-bye, quick tomorrow!